Hey guys, so today I'm going to be going through Math 200, Chapter 1 topics, which is all about data collection. So really, this is kind of the basis for the rest of the statistics class that you're going to be taking. So we're going to start with section 1.1, which introduces you to the practice of statistics. So there are a lot of definitions in this chapter, and one thing I'm going to recommend to everyone is to go ahead and read your textbook on this section. I'm going to go through a lot of the things here, but it will definitely help you to be reading your textbook for this particular chapter. So, first definition is the actual word statistics. So, statistics is actually the science of collecting, organizing, summarizing, and then analyzing information in order to draw some kind of conclusions or to get some kind of question answered. In addition, statistics is about providing a measure of confidence in any conclusion. So we're never going to be 100% sure that something is true, but we're able to provide some kind of measure of confidence around our conclusions that we can make. Now, the information referred to in the definition is data. So data are a fact or proposition used to draw a conclusion or make a decision. Data describe characteristics of an individual. So basically, it can be something like eye color or height, or really any characteristic around some kind of individual. A key aspect of data is that they vary. Okay, so is everyone in your class the same height? Absolutely not. Among individuals, there is variability. So, one of our goals in statistics is to actually describe and then understand the different sources of variability. So, the entire group of individuals that we want to study is called the population. So, that's this right over here. This is everyone that we're interested in. An individual is just a certain person or an object that is a member of the population being studied. So, it would be any one of these individual people. Now, a sample is a subset of the population that's being studied. So, typically, when we're trying to find something out, we're not able to actually ask everyone in the population to answer our question. So, what we do is we take something called a sample. So this right here is an example of a sample of our population. So we took our entire population and then we only took 6 of the people out of that. That's going to be our sample. Some more definitions here. So descriptive statistics consist of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, graphs. Now, a statistic is a numerical summary that's based on a sample, and a parameter is a numerical summary based on a population. So, if we have access to the entire population and we're able to get some kind of value from everyone, that's going to be a parameter. But if we take a sample, which is what we're typically doing, then we actually have a statistic. Now, inferential statistics, basically, it's the process of using some kind of method that takes results from a sample and extends them back onto the population and then measures the reliability of the result. So the whole idea with statistics is that we take our population, which is what we're interested in, we take a sample from that population, since it's too time consuming and too costly to actually ask everyone what we're interested in. So we take that sample and we get a statistic, and then inferential statistics allows us to take the statistic that we obtained in our sample and take those results, extend them back onto the population, and also give some kind of level of confidence around that conclusion. So let's look at an example where we're distinguishing between parameters and statistics. So let's suppose that the percentage of all students on your campus who have a job is 84.9%. Now, this value in particular represents a parameter because it's a numerical summary of a population. So it didn't tell us that we took a sampling of students on our campus. It just says the percentage of all students on your campus. So that's everyone. So that's going to be a parameter because it's from the actual population. Now, let's look at this. Suppose a sample of 250 students is obtained, and from this sample we find that 86.4% have a job. So we only took 250 students, which is a sample. So since our value is from a sample, it's going to represent a statistic. Okay, so statistics are from samples, parameters are from populations. These should be pretty easy to remember because they are each paired with the word that starts with the same letter. Statistic, sample, parameter, population. Now, there are several steps involved in the process of statistics, and this isn't something that you need to memorize. It's just something we want to talk about, make sure you understand it. So the first step in the process of statistics is to be able to identify the research objective. So basically just trying to decide what we're going to be researching. Step 2 would be to collect any information that's needed to answer the question. Step 3 would be to go ahead and describe the data. So you always want to take whatever data you collected and organize it nicely, summarize that information. And then hopefully you'll be able to draw some conclusions, which would either basically support the research objective or fail to support it. So let's look at an example here. So many studies evaluate batterer treatment programs, but there are very few experiments that are designed to compare batterer treatment programs to non-therapeutic treatments like community service. So what researchers did is they designed an experiment in which 376 male criminal court defendants who were accused of assaulting their intimate female partners were randomly assigned either into a treatment group or a control group. So the subjects in the treatment group entered a 40-hour batterer treatment program, while the subjects in the control group received 40 hours of community service. And then after 6 months, it was reported back that 21% of the males that were in the control group, meaning the ones who received community service, had further battering incidents, while only 10% of the males in the treatment group had further incidents. So the researchers concluded that the treatment was effective in reducing repeat battering offenses. So step 1 would have been to identify the research objective, and in this particular situation, it's to determine whether males accused of battering their intimate female partners that were assigned into a 40-hour treatment program are less likely to batter again compared to those who are just assigned to the typical 40 hours of community service. Step 2 was to collect the information. So in this particular example, the researchers randomly divided the subjects into 2 different groups. Group 1 participants received the batterer treatment program, while Group 2 participants received the community service. And then 6 months later, data was collected on the percentage of males that battered their intimate female partners again. Describing the data, so the demographic characteristics of the subjects in the experimental and control groups were similar. This helps us kind of control for any lurking variables. And then after the 6-month treatment, 21% of the males in the control group had a further battering incident versus 10% of the males in the treatment group. So that was the data that was actually collected and summarized. Now, conclusions that were drawn from this data, so we'll learn how to make these types of conclusions, but when they extended the results of the 376 males in the study, basically they were able to determine that males who batter their female partner and participate in a batterer treatment program are less likely to batter again than those who just receive community service. All right, some more definitions here. So variables are the characteristics of the individuals within the population. So the key point with this is that variables vary. So if you consider the variable height, we can use height to kind of describe someone. But if all individuals had the same height, then obtaining the height of one individual would be sufficient for knowing the height of everyone. Now, we know that this is not true. So as researchers, we want to identify the factors that influence the variability. So why is height different? So there are a couple different types of variables we're going to be talking about. We have qualitative or categorical variables. Those allow for classification of individuals based on some attribute or characteristic. Quantitative is kind of the opposite of that, provides a numerical measure of individuals. So arithmetic operations can be done like addition or subtraction. They can be performed on these values and provide some kind of meaningful results. So let's look at some examples that we have here. So let's go through this kind of study here, pull out some of the variables, and determine if they're quantitative or qualitative. So researcher Elizabeth, I'm not sure how to say this last name, and others studied factors that affect the eating habits of adults in their mid-30s. We want to classify each of the following variables considered in the study as qualitative or quantitative. So nationality is going to be qualitative because it doesn't have any kind of numeric value. It takes on some kind of value that would be an actual word. So that's a big key to tell you that it's qualitative. Number of children is quantitative because it's a number. Okay, same thing with household income. Level of education, this would be qualitative because we would have a high school grad, less than high school grad, some college, college degree, advanced degree. Those would be our different levels of education there. And then daily intake of whole grains measured in grams would be quantitative because that's going to be some kind of number. Now, we also have the ability to take quantitative variables and to split it into two groups, discrete and continuous. So a discrete variable is some quantitative variable that has basically a countable number of possible values. And what we mean by that is basically it's going to be a whole number, okay? So it can only take on values like 0, 1, 2, 3, and so on. Continuous variables basically have an infinite number of possible values. They can be measured to any desired level of accuracy. So for example, it could take on the value 1.27 or something like that. Okay, so let's take a look at the numeric values that we were talking about before and determine if they're discrete or continuous. So if you think about number of children, you cannot have half a child, okay? You have to have a whole number of children, so that's going to be discrete. Now with household income, that one's going to be continuous because maybe this is rounded to the nearest dollar, or maybe it's taken all the way out to cents. Okay, so maybe you make $60,432.05. Okay, so it's not just whole numbers. And then the same thing for daily intake of whole grains measured in grams per day. So you could definitely eat half a gram of whole grains or a third of a gram and so on. So that's going to be continuous as well. Now, the list of observations a variable assumes is called data. While gender is a variable, the actual observations, male or female, are going to be the actual data points. Qualitative data are just observations that correspond with a qualitative variable. Quantitative data are observations that correspond to a quantitative variable. Discrete data are the observations that correspond to a discrete variable, and the same thing with continuous. So this is just additional terminology. If you understand the difference between qualitative, quantitative, discrete, continuous, that's kind of the big key that you need to take away from here. Now, we also have levels of measurement, and these are slightly trickier, so I want to spend some time on this. But a variable is at the nominal level of measurement if the values of the variable name, label, or categorize. The naming scheme does not allow for the values of the variable to be arranged in any kind of order. So there's no real order associated. So that's just going to be nominal. Now, ordinal level of measurement has the same properties as nominal, but the naming scheme does allow for some kind of ranking. Okay, so the order actually matters. Now with interval, we have something where the difference in the values have some kind of meaning. Now a value of 0 in the interval level of measurement does not mean the absence of quantity. Now addition and subtraction can be meaningfully performed on values in this particular category. And then ratio is the last one, and it has the same properties of interval, but also the ratios of the values have some kind of meaning. A value of 0 means the absence of quantity. So basically for this one, for ratio, 0 equals 0. It means that there's actually nothing. And multiplication and division can be performed on these values. So let's take a look at some of these examples. We don't need to read this whole study. I just want to look at the examples that we have down here, and we want to determine the level of measurement for the following variables. So for A, we have number of snack and soft drink vending machines in the school. So for this particular one, 0 is actually equal to 0. So it's entirely possible that in a particular school, there are no snack and no soft drink vending machines. So 0 is actually equal to 0. So that's going to be a ratio level of measurement. Now, whether or not the school has a closed campus policy during lunch, that's going to be nominal. So that would either be yes or no, but there's no real associated order there, so it's just nominal. Now for C, we have class rank, freshman, sophomore, junior, senior. So for this particular one, there is some kind of associated order. So this one's going to be ordinal. And then D, number of days per week a student eats school lunch. This one's also ratio because a student can eat school lunch 0 days a week, and that is an absence of quantity. It means that they do not eat school lunch on any days. All right, let's take a look at section 1.2, which talks about observational studies versus designed experiments. So, some definitions again. So, in research, we wish to determine how varying the amount of an explanatory variable affects the value of a response variable. Now, an observational study measures the value of the response variable without attempting to influence the value of either the response or the explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals in the study without really influencing the outcome of the study at all. Now, if a researcher assigns individuals in a study to a certain group, or intentionally changes the value of the explanatory variable and then records what actually happens, then that's a designed experiment. So observational study, we're just seeing what's happening without really changing anything. Designed experiment, they've actually designed what they want the experiment to look like. So let's look at this flu study example. So researchers wanted to determine the long-term benefits of the flu vaccine on seniors aged 65 and older. So the researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into two different groups. Group 1 were seniors who chose to get a flu vaccine, and Group 2 were seniors who chose to not get a flu vaccine. Now, after observing the seniors for 10 years, it was determined that seniors who get flu vaccines are 27% less likely to be hospitalized for pneumonia or the flu, and 48% less likely to die from pneumonia or the flu. So, based on the result of this study, would you recommend that all seniors go out and get a flu shot? So, no. Obviously, the results show that seniors who get the flu shot do have benefits, but this study might have flaws. So this particular study was just looking at what was happening. It was an observational study, and the main issue is that confounding may be a problem. Now, confounding in a study occurs when the effects of two or more explanatory variables are not separated. So any relation that might exist between an explanatory variable and a response variable, both might be due to some other variable that's not accounted for. So for example, there could be things in this particular study that have basically affected whether or not a senior gets the flu vaccine, and also affected whether or not they get pneumonia or the flu in the future. So they didn't account for all of these things, okay? So confounding is an issue in this particular case. Now, a lurking variable is some explanatory variable that was not considered in a study, but that affect the value of the response variable. So lurking variables are typically related to any of the explanatory variables considered in the study. So for example, it could be the senior's particular age, or marital status, or whether or not they've gotten a flu vaccine in the past, if they eat well, okay, if they're overweight, that kind of thing. Those are all possible lurking variables. So in this case, they listed some more here. So age, health status, mobility of the senior, those are all things that can also affect whether or not that senior gets the flu or pneumonia in a given year. So even after accounting for potential lurking variables, the authors of the study did conclude that getting a flu shot is associated with a lower risk of being hospitalized or dying from the flu. But since this was an observational study, meaning we just observed what happened with these seniors, we can't actually say that one caused the other. We can say that the two things are associated, but it's impossible to conclude causation from an observational study. Now, there are some other types of observational studies we're going to talk about, so these are like specific subcategories. So cross-sectional studies are observational studies that collect information about individuals at some specific point in time or over a very short period of time. Case control studies are retrospective, meaning that basically they require individuals to look back in time, and they require the researcher to look at existing records. So basically, they're just looking backwards in time. And then cohort studies are studies that follow people over time. Okay, so people are followed over a certain time period, and characteristics about that individual are recorded. So this is a prospective study. So let's look at this example here. Researchers wanted to assess the long-term psychological effects on children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43. The subjects' mental states were evaluated using questionnaires, and it was determined that the psychological well-being of the individuals was adversely affected by evacuation. So in this particular case, they didn't take these people and then follow them throughout time. They just asked them to basically fill out a survey. So this is going to be a case control study where someone is retrospectively looking back in time to see what happened. All right, let's look at this one here. Xylitol has proven effective in preventing dental cavities when included in food or gum. So a total of 75 Peruvian children were given milk with and without xylitol, and then they were asked to evaluate the taste of each. And overall, the children preferred the milk that was actually flavored with xylitol. So this is going to be a designed experiment, okay, in this particular case, because they actually had children taste it both ways. And if we knew a little bit more about this, it would be a little easier to tell. But it is possible from the information we're given to kind of tell that it was designed in a specific way. We weren't just observing what was happening. All right, let's look at this one here. A total of 974 homeless women in the LA area were surveyed to determine their level of satisfaction with healthcare provided by shelter clinics versus healthcare provided by government clinics. And then the women actually reported greater quality satisfaction with the shelter and the outreach clinics compared to the government clinics. This one's going to be cross-sectional, so we're just looking over a very short period of time and asking them to answer some questions. It's an observational study, but it's cross-sectional. And finally, this one here, cancer prevention study, funded and conducted by American Cancer Society, and its goal was to examine the relationship among environmental and lifestyle factors on cancer cases by tracking 1.2 million men and women. And it looks like in 1982 they provided some information. Vital statistics are updated biannually. Cause of death has been documented for over 98% of all deaths that have occurred, and then mortality follow-up of the CPS2 participants is complete through 2002, and it's expected to continue for many years. So this is going to be a cohort study because we're taking these people and over time we continue to track them, okay? So this is, again, we're just observing what's happening. We're not changing anything about these particular men and women, but we're studying them over time. So this is a cohort. Now, a census is actually a list of all individuals in a population along with certain characteristics of each individual. So you've probably heard of the census before because every 10 years in the United States, a census is done. The last one was in 2010. And that's when information is collected from every single person in the US, or at least everyone that they're able to get to respond, regarding things like socioeconomic status and how many children are in your family, that kind of thing. So the reason that we can't take a census for every single thing that we're interested in is that it's very time consuming and very costly. So that's why it's done only every 10 years. All right, let's take a look at section 1.3, which talks about simple random sampling. So random sampling is the process of using chance to select individuals from a population to be included in a sample. So we talked about the fact that we cannot possibly ask everyone a question when we're interested in something, so we have to take a sample. Now, if convenience is used to obtain a sample, meaning you're only doing what's convenient in order to obtain some sample, the results of the survey are going to be pretty meaningless because there's going to be so many issues from just selecting people where it's convenient. Now, a sample size of n, this is little n, okay, little n is always going to represent sample size. Big N represents population size, and it's obtained through simple random sampling if every possible sample size of size n has an equally likely chance of occurring. Now, that's called a simple random sample. So let's suppose that we have a study group of 5 students, Bob, Patricia, Mike, Jan, and Maria, and 2 of the students have to go to the board to demonstrate some homework problem. So what we would do is we would list all possible samples of size 2 without replacement, and we would come up with these 10 options: Bob and Patricia, Bob and Mike, Bob and Jan, and so on. So if we were to do a simple random sample, we'd obtain a frame, and that's what we just did, that lists all of the individuals in the population of interest, and then we numbered it. And then we would use some kind of random number table, or we could use a graphing calculator, or we could use statistical software to randomly generate a certain number of numbers. And then we would select those particular people. So let's take a look at this right here. So the 112th Congress of the US had 435 members in the House of Representatives. Explain how to conduct a simple random sample of 5 members, then obtain the sample. So step 1 would be to put the members in some kind of order. Okay, we could do alphabetical order from 1 to 435. And then basically what you'd do is you'd randomly select 5 numbers using some kind of random number generator. You'd set the seed, which is kind of the initial starting point for the generator. And you could use a generator online, you could use a graphing calculator, it doesn't really matter. And the 5 numbers will be randomly generated, and then you would match them to the corresponding representatives, and those would be the 5 selected representatives to attend the presidential luncheon. All right, section 1.4 talks about other effective sampling methods. So this graphic, which is also in your textbook, I think is the most useful thing in this particular section because it just shows exactly what's happening with these different types of sampling. So simple random sampling is what we just talked about. Basically, it's just completely random, okay? So we took all of these people in our population and randomly selected 3 of them using some of the methods that were talked about in the previous slides. Now we're also going to talk about stratified sampling, and then systematic sampling and cluster sampling. So to just see what's going on here, with stratified sampling, we took the whole population and then we broke it into different strata, different groups. And what you can see in this case is that we've broken our people here up into men and women. Okay, so we have divided it by gender. And then within the male category, we took a representative sample, okay, probably a simple random sample from there. And we also took some kind of sample from the women as well. So we ended up with these 4 people in our sample. We have people from each gender group. Systematic sampling, you can see every 3rd person was selected, starting with the 2nd person. So basically we had people in a line, and we took the 2nd person, and then we skipped 2 people, took the 3rd person, skipped 2 people, took that next person, skipped 2 people, next person. So this kind of has a system involved. And then cluster sampling, basically what we did is we took all these people and we broke them into clusters, okay? This is often useful when we're talking about some kind of geographic cluster, okay, like neighborhoods or something like that, where people are automatically sort of clustered into some kind of logical group. And then we select certain clusters and randomly include everyone basically that are in the randomly selected clusters. So we picked basically this first cluster and this 5th cluster and took everyone in those particular groups. So now we're going to look at some definitions that relate back to those. So a stratified sample is one that's obtained by separating the population into some non-overlapping groups called strata, and then obtaining a simple random sample from each of those strata. Now the individuals within each stratum should be similar in some way, okay? So they should have some kind of grouping. The last one we talked about was gender. So let's look at this example here. In 2008, the US Senate had 47 Republicans, 51 Democrats, 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other person. So we want to obtain a stratified sample in order to select members who will attend the luncheon. So in order to obtain this, we would just basically conduct a simple random sample within each of the groups. So we would take the 47 Republicans and randomly select 4. We'd take the 51 Democrats and select 4, and we'd take, the 2 independents and randomly select 1 person. Or I'm not sure if the others should be independent or out of everyone, but you get the idea. And we would use a different seed for each of the stratum that we're selecting from. Now, a systematic sample is obtained by selecting every kth individual from a population, and the first individual selected is a random number between 1 and k. So there are some steps involved in this. It's not too difficult. It's a little weird to kind of look at, but let's go through these steps, and you'll see in your homework how you might actually use this. So step 1 would be to determine the population size, which again, we're using a capital N, to denote the population. And then we determine the sample size, which is little n. And then what we do is we divide, okay? So we take our population size and we divide it by our sample size and we round it down to the nearest integer. That's going to be k, okay? Now you're going to randomly select some number between 1 and k, and you're going to call this number p, okay? That's basically the value you're going to start with. So the sample is going to consist of person p, okay? So the first person or the second person of the third person. And then every time you're just adding k, okay? And that's going to be your next person. And then you add k again, until you've taken your entire sample. Now, a cluster sample is obtained by selecting all individuals within a randomly selected collection of group or individuals. So let's say that a school administrator wants to obtain a sample of students in order to conduct a survey. So what she does is she takes the entire list of classes, okay, and she randomly selects 10 of the classes. And then she administers the survey to all of the students in each of those 10 classes. So she's using simple random sampling to select the classes, but then she's actually asking everyone in those classes to fill out the survey. Now, a convenience sample is one in which the individuals in the sample are easily obtained. And big exclamation point here, caution symbol. Any studies that use this type of sampling generally have results that are suspect. So results should be looked at with extreme skepticism for this type of sample. It's not reliable, okay? You're not going to get individuals that are actually representative of your population. And one other type of sampling is multistage sampling, where basically a combination of the techniques are used. And most large-scale surveys are going to be some kind of combination of those techniques. So just to give you an example, you might have heard of Nielsen Media Research. They do all of the television program monitoring. So Nielsen randomly selects households and then monitors the television programs that they watch using a people meter. Meter, I think, is just an electronic box that's placed on the TV within the household. And the people meter measures what program is being watched and who is watching it. So Nielsen selects the households using a two-stage sampling process. The first thing that they do is they use census data to divide the country into some kind of geographic areas, okay, and I'm not sure what those geographic areas are. It says typical city blocks in urban areas, and then geographic regions in rural areas. So there are about 6,000 strata then that are randomly selected, and then Nielsen sends representatives to these 6,000 strata that are selected and then lists the households within each. And then within each of these strata, households are randomly selected using simple random sampling. So you can see it's two different types of sampling done here. Nielsen then sells this information obtained to television stations and companies, and it's really used to help determine the prices for commercials. Now, section 1.5 is about bias in sampling. So first, some definitions. So if the results of the sample are not representative of the population, then the sample has bias. And there are three sources of bias. There's sampling bias, non-response bias, and response bias. Sampling bias basically means that the technique used to obtain the individuals in the sample tends to favor one part of the population over another. So one part of the population is overemphasized. Undercoverage is a type of sampling bias, and undercoverage occurs when the proportion of one segment of the population is lower in a sample than it is in the population. So basically, we didn't take a large enough proportion of people from some specific group. Now, non-response bias exists when individuals selected to be in the sample don't respond to the survey, and that those people have actually different opinions than those who do respond to the survey. Now, non-response can be improved through the use of callbacks or incentivizing people to respond. So basically having phone surveyors call people back again and again or offer them some kind of reward for their response. Now, response bias exists when the answers on a survey do not reflect the true feelings of the respondent. There are several types of response bias. One can be interviewer error. There can also be misrepresented answers, wording that's used in survey questions, or the ordering of the questions. Non-sampling errors are errors that result from sampling bias, non-response bias, response bias, or some kind of data entry. And these errors could also be present in a complete census of the population. So all of these things can happen even with an entire census of the population. But sampling errors are errors that result from using a sample to estimate information about a population. And this type of error occurs because a sample gives incomplete information about a population. So since we're not able to ask everyone what their opinion is on a particular topic, we take a sample. And this sample is going to introduce some kind of sampling error because we can't get complete information about the population from a sample, but this is kind of understood. This is something that we manage. So let's talk about section 1.6, which is the design of experiments. So an experiment is a controlled study conducted to determine the effect of varying one or more explanatory variables or factors and how that has some kind of an effect on a response variable. Now, any combination of the values of the factors is called a treatment. Now, the experimental unit, or another word for that is the subject, is just a person, an object, or some other well-defined item upon which a treatment is applied. A control group is a baseline treatment that can be used to compare to other treatments. And a placebo is some kind of innocuous medication, like a sugar tablet. Basically, it looks, tastes, smells like an experimental medication, but it's really just a sugar tablet. It doesn't really do anything. Now, blinding refers to non-disclosure of the treatment an experimental unit is receiving. So a single-blind experiment would be one where the subject doesn't know which treatment he or she is receiving. And then a double-blind experiment, which is ideal if possible, would be one where neither the subject nor the researcher in contact with the subject knows which treatment the experimental unit is receiving. So, for example, if they're doing some kind of hospital designed experiment to determine if this is an effective treatment for cancer. Basically, if the person who's administering the medication and the person who's receiving the medication both don't know if the medication is the actual medication or a placebo, then that would be an example of a double-blind experiment. So let's look at an example here. The English department of a community college is considering adopting an online version of the freshman English course. So to compare the new online course to the traditional course, an English department faculty member randomly splits a section of her course. So half of the students receive the traditional, the other half are given an online version. And then at the end of the semester, both groups are given a test to determine who performed better. So the experimental units in this case are the students that are actually in the class. Population for which the study applies would be all students who enroll in freshman English course. The treatments are going to be the traditional versus the online instruction. Response variable would be the actual exam score. And why can't this experience be done with blinding? Basically, a student is going to know if they're in a face-to-face class or an online class. And the instructor is also going to know if they see that student or if that student is just online. So there's no way to keep that a secret. Now, to design an experiment basically means to describe the overall plan in conducting the experiment. So step one would be to identify the problem that you want to solve. This should be explicit. It should provide the experimenter with direction. It should identify a response variable and the population, and this is often referred to as the claim. Now, step two would be to determine the factors that actually affect the response variable. And once the factors are determined, it has to be determined which factors are fixed and which ones are going to be manipulated and which others are potentially just uncontrolled. Step three would be to determine the number of experimental units. Step four would be to determine the level of the predictor variables. So with control, there are basically two ways to control the factors. You can either fix their level at one predetermined value throughout the experiment, or set them at some kind of predetermined levels. So these are the factors whose effect on the response variables interest us. The combinations of the levels of these factors represent the treatments in the experiment. So basically that's what we're varying. When we're fixing something at one predetermined level, that's something that we don't care about. We want to control for it, but we don't actually care about the effect that this variable has on the response variable. And then we also want to randomize the experimental units to various treatment groups so that the effects of the variables whose level cannot be controlled is minimized. The idea is that randomization kind of averages out the effects of the uncontrolled predictor variables. And then we actually conduct the experiment. Now, replication occurs when each treatment is applied to more than one experimental unit. And this helps to assure that the effect of the treatment is not due to some single character or some characteristic of a single person. And it's better to have a slightly larger sample, to have enough replication to be able to tell if the effect that you're seeing is real or not. And then you collect and process the data by measuring the value of the response variable for each replication, and any difference would be recorded. And then you go ahead and test the claim. Now, this is what we're going to be dealing with in the latter half of the class. We're actually going to be using inferential statistics in order to make generalizations about a population based on the results of a sample. So we take our sample, we're able to generalize it back onto our population using some kind of inferential statistics. And then we provide a statement regarding the level of confidence. So I mentioned earlier we can never really be 100% confident about a conclusion that we make, but we can tell people how confident we are. Now, a completely randomized design is one in which each experimental unit is randomly assigned to a treatment. So let's look at this example here. The octane of fuel is a measure of its resistance to detonation, with a higher number indicating higher resistance. An engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. Assist the engineer in designing an experiment. So step one would be to determine the response variable, which would be miles per gallon. Now, the factors that are going to affect miles per gallon, you can kind of just think about this, but engine size, outside temperature, driving style, driving conditions, the characteristics of the vehicle, that kind of thing. There are probably a lot of other things than just those. Step three, now this we wouldn't know without some other information, but the example we're going to walk through, we're just going to use 12 cars, all the same model, same year. And we're going to list the variables and their levels. So we would have octane level manipulated at 3 different levels. We'd have 87, 89, and 92. Engine size is going to be fixed since we're using cars from the same model and same year. Temperature would be uncontrolled, but it should be the same for all 12 cars. Driving style and conditions. So with this, all 12 cars should be driven under the same conditions on a closed track by the same person. And since all 12 cars are the same model year, there is some possibility for variation from car to car. So in order to account for this variation that we might not be able to otherwise, we're going to randomly assign the cars to the octane level so that hopefully things kind of, since they're random, they're going to kind of even out. Now, step 5 would be to randomly assign 4 cars to 87, 4 cars to 89, and 4 cars to 92. And then one way we could conduct this particular experiment would be to give each car 3 gallons of gasoline and basically drive until they run out of gas, and then compute the miles per gallon. And then we would use some kind of inferential statistics to determine if any differences exist, and use this to generalize about our population. So if you look at a picture here, we have our 12 cars. We've split it into 3 groups of 4, and then they're randomly assigned a treatment of 87, 89, or 92 octane, and then the miles per gallon are then compared. So this is just a really quick overview, okay, of what we're going to be doing in this class. This is basically what this chapter is setting you up for. I would highly recommend that you go ahead and read the textbook, as I mentioned earlier, to get some more detail and more examples about this. Doing the homework will also help you kind of solidify these concepts in your brain by getting to read through some studies and answer some questions.